Hi there, hope you're well. This video will help explain the process that we use to multiply and divide polar complex numbers. Okay, I hope you'll find that it's pretty easy to do. Here's a couple of example numbers that we're going to use. First one is 3 times cosine of 120 plus I sine 120, and the second one is 6 times cosine 30 plus I sine 30. Yes, we're using degrees for these examples, but the process, of course, is the same whether you are using degrees or radians. It just so happens that degrees makes the arithmetic a little bit easier, and you'll see why pretty soon. Okay, so here's our first two numbers, and we are going to first multiply them. And the process to multiply two polar complex numbers, you simply multiply the moduli together and add up the arguments. That's all you have to do. Moduli, of course, as you recall, is plural for modulus, so that's the R values. And arguments, well, that's a general term for any input value into a function, and of course, in this case, we mean theta. So you multiply R's and you add the thetas, and that's all you got to do. So to multiply Z1 times Z2, I first have to multiply 3 times 6. Well, that was tough. And then I have to add up 120 plus 30. Ooh, pretty tough. And you can see why using degrees here makes that a little bit simpler sometimes rather than adding fractions of pi. But that's it. That is really pretty much the only thing that we have to do to multiply those two numbers together, and except to finally just write the answer out, which there you see, 18 times cosine of 150 plus I sine 150. Let's try dividing. Dividing is, as you might expect, an inverse operation from multiplication. So to divide, you simply divide the two moduli together and you subtract the arguments. No big deal. So if I take Z1 divided by Z2, all I have to do is take 3 divided by 6, that's 1/2, and I take 120 minus 30, that's 90. There you go, you're pretty much done. 1/2 times cosine of 90 plus I sine of 90. That's the answer. There's nothing else really to do there. So just to summarize the little process here, you multiply the moduli and add up the arguments. That's how you multiply two polar complex numbers. And to divide them, you simply do the inverse of that. Divide the moduli and subtract the arguments. Now the only other possible wrinkle in this otherwise very smooth process would be that you may, after doing this, end up with a number for theta that is greater than 2 pi, or greater than 360, or maybe even less than 0. So if that's the case, you should strive, by whatever means is required, to keep your theta value between 0 and 2 pi. Or if, like our examples, you were using degrees, keep it between 0 and 360. And so you've dealt with that problem before in other study of trigonometry, so I won't go into it in this video here. But that's just a convention that we try to respect as we do these problems. Okay, that's it for now. The next video will talk about raising polar complex numbers to higher powers and finding the roots. Very fun stuff. Bye-bye.